Tools is a new software to display various measurements performed by Viber X5. It lets you open different kinds of measurement files, view them on your computer, and to some extent analyze them and eventually create a report in PDF format or for paper printing. To install the software, right-click and choose Run as Administrator. It is recommended that you install the software directly on the C drive. Click Install. When the installation is completed, click Close. You can now see that a shortcut to Tools has been added on your desktop. On your hard drive, under Tools, you can see there are two folders of interest. The first one is Reports. Here, all the reports created in Tools will be saved. The second folder is X5 data. In this folder, there are several other folders with different types of measurement data. If the software is uninstalled and a newer version is installed instead, this folder and all of its content will remain the same. The version of the software is always shown in the top left corner. There are two parts of this program: Settings and Measurements. To import, turn off your Viber X5, plug it into your PC via a USB cable and click Import. A new screen will appear asking if you want to import X5 data. By clicking Automatic, everything is imported, and if there are several files with the same name, the new one will automatically be renamed. If you instead click Manually, you can choose exactly which data files you want to import. By clicking Make Header, you can customize your own header for the reports you create. You can change your logo by clicking on Change and choose an image from your computer, PNG, JPEG, or BMP. Here, you can enter information such as company name and address. Click Save. Let's go over to the measurements. When you click on Spectra, you're directly sent to the X5 data folder. We start off by choosing an advanced spectra. So under Spectra, and choose ASP for advanced spectra. The files from the Viber X5 is saved with numbers starting from 1. Every window has an ID shown in the top right corner, and we'll come back to that later. The Viv1 is marked red on both the cable and the socket, and therefore this graph is also red. Same thing with the Viv2, but this one is blue. In this case, we have used a 3-axial transducer, and therefore we have these three graphs: red for X, blue for Y, and green for the Z direction. The marker is by default set to the highest top. We can see that this gives us an amplitude of 15.3 millimeters per second, a frequency of 49 Hz, and the rotor speed, which in this case is 2,938 revolutions per minute. Here, we have chosen to save the speed when we perform the measurement with the Viber X5, and therefore it can be displayed. Otherwise, it would appear NA which means not available. If you click harmonic, the harmonics of the current frequency will be shown. If you move the marker by clicking the left mouse button and dragging, or taking one step at a time with the keyboard arrows, the harmonics will move as well. Notice that the speed does not change because it's only showing the speed of the rotor. If you activate sidebands, harmonic will be deactivated, and this gives us 4 lines on each side of the current frequency. The distance between these lines is by default set to 4 Hz. We can go ahead and change this to, for example, 49 Hz. If we want to deactivate sidebands, just click it once more. To zoom the graph, click the zoom button. By doing this, you can left click and select the area you want to zoom in on. The graph is zoomed in both X and Y directions. If you want to go back, just right click somewhere in this area. After you've zoomed out, the zoom function is automatically deactivated. If we click wave, we will get a waveform with amplitude on the y-axis and time in milliseconds on the x-axis. Speed remains the same. To go back, click on the same place where you now see spectra. Note that wave is available only if it has been selected to be saved when the measurement was performed by the instrument. To show the graph in the logarithmic scale, click this button. The y-axis is now shown in decibel and the x-axis in hertz. And to go back, click linear. If you click next view, the first graph is shown. Here, the speed is also given in hertz. In the bottom right corner of the screen, you can write comments. For example, Department 1, Machine 4, drive side, horizontal. This will now be included in the final report. Harmonic, sidebands, and the other modes can be used here as well. When you click harmonic, the frequency of each harmonic is shown to the right here. If you click sidebands, you see 8 small windows divided into 2 groups. 4 to the left, containing values smaller than the marker's frequency, since these are frequencies coming before the marker, and 4 frequencies greater than the marker frequency, since they come after the marker. If the bands go out of the frequency area, out of range is shown in the corresponding window. So if I go ahead and move this marker, we can see that we obtain values in the windows. By clicking Next View, the second graph is shown. We'll write some notes for the report here as well. And if we click Next View one more time, we will see the last graph. Next View will now take us back to the first screen. If you want to include this and other measurements in the same report, don't close the window, just minimize it. Now let us load a basic spectra. Click on Spectra. The program remembers the last folder you were in. Choose the file named PSP. Here, two accelerometers have been used. VIB1, represented by the red color, and VIB2, represented by a blue color. In this case, no tachometer was used, meaning speed will say NA for not available. Harmonic, sidebands, zoom, and logarithmic work the same way here. Waveform has not been saved in this file, and therefore the wave button is gray and not clickable. In this case, we don't want this to be included in the report, so we click Close. Now click Envelope. Go back to your X5 data folder. Go to Envelope and load your file. Here, the y-axis is represented in GE for G envelope, and the x-axis in Hertz. In this case, we have used a tachometer, which means we have obtained the speed. The exact amplitude can be read from the y-axis, and we also have the frequency. Harmonic, sidebands, zoom, wave, and logarithmic is the same as before. Click Next View. In the top right corner, you'll find amplitude, frequency, and speed. You can write comments for the report just as before. Click Next View. And one more time. Let's minimize the screen to later include it in the report. Now, let's choose Coast Up. Go to the folder. And choose the file. Here, we have used two accelerometers, one for VIB1 and one for VIB2. What we see here is two graphs, one showing changes in phase, and the other showing changes in amplitude. But both show result for VIB1, therefore the graphs are red. Note that the graphs are still connected, so that if you move the marker on one graph, it will move on the other as well. In the first graph, the y-axis is shown in degrees from 0 to 360, and the x-axis is shown in hertz. In the second graph, the y-axis is shown in millimeters per second. In the top right corner, you can see the amplitude, the phase, and frequency in both hertz and revolutions per minute. Left click and drag to see the different values for the different positions. Let's write some comments here. When zoom is used here, by clicking the button and left clicking, dragging, the graph is only zoomed in along the x-axis. Right click to go back. Click next view to see the graphs from Viv 2. All tools work exactly the same here. And we'll write some notes as well. So let's minimize it. Now go to coast down. Choose the file. All the tools here work just as for the coast up. The next one is orbit. Choose your file. Here we've got the time in milliseconds on the x-axis and the amplitude in micrometer on the y-axis. You can choose among several different time gaps, starting from 50 milliseconds Comments for the report can also be written here. Let's see how the sync spectra works. Under spectra, choose the file named SSP. The different tools work just as we saw earlier in, for example, the advanced spectra. Let's write some comments. And let's minimize it. Now click cross spectra. And under C spectra, choose your file. Here we have Vib1, Vib2, and a third graph called cross spectra, which is showing the difference between the spectras. If you left click and drag the marker in the cross spectrograph, all the markers will move simultaneous. Also here you can use your keyboard arrows to move. Under the cross spectrograph, you can see values for the amplitude of the cross spectra, frequency, the phase, and the amplitude for both Vib1 and Vib2. We'll write some notes again. Click next view. Remember, in the right corner, you can see the frequency and the phase and the amplitude. Next one is bump test. And under this folder, choose your file. To move the lines, left click and grab the green line. Move it to the right or to the left. To change the distance between the lines, click plus or minus. In this case, zoom means zooming in the area between the lines. You can go back by clicking zoom again. When you've chosen a span, click Spectra. The top here is the resonance frequency. Since we have just one bump in the beginning of our time signal coming before the 2-second mark of our 8-second time signal, we can choose the highest band, 4000 milliseconds. This means that we get a resolution of 0.25 Hz. This allows us to detect accurate resonance frequency with very high resolution. So when I click the keyboard arrows, you can see the frequency is changing by 0.25 Hz. Harmonic, sideband, zoom, and logarithmic work exactly the same way here. Now let's go to IR to show thermal imaging. Click IR and under the folder IR temp, choose your file. This picture shows the hot object where 30.2 degrees is the lowest temperature in the image, represented by the darkest color, and 155.5 degrees in the highest temperature, represented by the lightest color. This value shows the temperature on the position where the marker is. If I left click somewhere in the picture, you can see the values changing. By default, the marker covers the smallest possible area. To change this, click plus or minus, or scroll with your mouse wheel. The temperature is an average value of the area. We can show the image in color or grayscale. And for the temperature, we can choose both Celsius and Fahrenheit. We can write some notes here as well. The next one is MCSA. And under the folder, choose your file. Here, the y-axis is given in decibel, and the x-axis in hertz. The frequency on the highest top is marked. S1 is the side frequency 1 located on the left side, which means a lower frequency than the center frequency. S2 is the side frequency 2 located on the right side of the center frequency, meaning a higher frequency than the center frequency. So for example here, we can see that side frequency 1 has an amplitude of 43.6 decibel. Delta 1 shows amplitude difference between side frequency 1 and the center frequency. And delta 2 shows amplitude difference between side frequency 2 and the center frequency. The green line shows the highest allowed amplitude of the side frequencies. Various tools like harmonic and sidebands work just as before, shown in the section about the advanced spectra. As always, values are shown in the top right corner. We'll continue writing some notes. And let's minimize the window. Let's take a look at the report. All open windows are shown here, along with their ID, the type, time, file name, and comments. You can choose what you want to include in the report. You can select one and move it to the right side, meaning you want to include it. If you want, you can select it and click delete to remove it from the list. You can also move all or delete all. But for this report, we want to include all. Let's say we want this one to come first in the report. To achieve this, we can select it and click move up. Or if we want it to come later in the report, we could select it and click move down. Now if we click make PDF, we can save our report. As default, the report will be saved in the folder reports. Click save and close the window. Now go to the reports folder under Xtools. We can now see that a report has been created. The header that was created, containing logo, address and date, is shown on all pages. The order we chose is right. All the graphs and comments are here as well. Next one is balancing. Choose your file under balance. In the top left corner, you can see the file name and the date when the balancing was performed. You can add comments by clicking comments. And from here we can directly click make PDF or click hide comments, and then make PDF. Name your report. Click Save and close the window. In the same folder as before, we can now see the newly created report. You can see it has the same header that was created before, along with the balancing data and comments. There is also space for a signature if needed. The last one is data logging. Go to Logging and choose your file. We'll name the report. Click Save. And in the same folder, we now find the new report. Here we can see when the measurement began, when it ended, number of recorded values, and information of used transducer. Here you will see the recorder number, the timestamp for this measurement is shown here, total value of the x-axis in millimeters per second RMS, amplitude of third harmony of speed frequency also in millimeters per second RMS, phase angle of third harmony of speed frequency in degrees, and these values are also obtained for the y and the z direction. And finally, the speed of the rotor at record time. Thank you for watching, and be sure to check out our website vmiab.com for more information on our great range of products.